Let's take a look at this example. This time we have given series circuit which contains voltage source, two resistors and inductor. Let's take a look what we have given. We have given voltage source and we have given inductance, frequency, and the values of two resistors. We have to find Z total. So in order to find Z total, we're supposed to find the impedance of the inductor, or other words, inductive reactance. We have to find ZL. ZL is equal to 2 pi FL. Okay, and remember we are going to have always angle 90 degrees. So this is equal 2 pi times the frequency, which is equal 3 kilohertz, times inductance, which is equal 25 millihenries. Use the calculator and you're supposed to get the value 471.23 ohms and angle of 90 degrees. Remember, anytime we talk about the impedance of a inductor, we're supposed to always add angle 90 degrees or J. Next, we can find Z total because we have two resistors given and we found the impedance of the inductor. You're supposed to write the formula. Z total is equal R1 plus R2 plus ZL. We're supposed to add them up because this is series circuit. R1 is equal 360 ohms plus R2, which is equal 470 ohms, plus ZL, which is equal 471.23 ohms, and angle of 90 degrees. Again, you're supposed to use the calculator and you're supposed to obtain the value 954.44 ohms, an angle of 29.58 degrees. So this is total impedance of my circuit. Next, we're supposed to find I total. Let me remind you that this is series circuit. In series circuit, the current at every single point of the circuit is going to be always the same. That's why KCL for series circuit, in this case, in our problem, this is going to be I total equals IR1 and equals to the current which goes through the inductor, IL, and this is also equal to the current which goes through resistor R2. So in order to find the current, I'm supposed to simply divide voltage source by Z total, where voltage source is equal 120 volts and angle of 60 degrees divided by Z total, which is equal 954.44 ohms, an angle of 29.58 degrees. Use the calculator and you're supposed to get the value 125.72 milliamps, an angle of 30.42 degrees. This is the current which goes through every single component. Next, we're supposed to find voltage across resistor R1. So VR1 is equal, I'm going to use Ohm's law this time, VR1 is equal IR1 times R1. current times resistance gives me voltage. So I have IR1, we calculate, is 125.72 milliamps, an angle of 30.42 degrees, times R1, which is equal 360 ohms. This is equal 45.25 volts and angle of 30.42 degrees. This is voltage drop across resistor R1. Next, we're supposed to find voltage across inductor. So if you want to find voltage across inductor, VL, you're supposed to simply multiply the current which goes through this inductor. Remember, the current in the circuit is the same everywhere. So I'm supposed to write IL times ZL, where IL is equal 125.72 milliamps, an angle of 30.42 degrees, times ZL, which is equal 471.23 ohms, an angle of 90 degrees. ZL goes always with angle of 90 degrees. Again, you're supposed to use the calculator. We will get the value of VL equals 59.24 volts and angle of 120.42 degrees. This is voltage across the inductor. Next, we're supposed to find voltage VAB. Voltage VAB is the voltage across these two components. So if you are going to add these two voltages together, you are going to find voltage VAB. Also, this is very important, in which direction the current will flow. I understand this is AC, but we're supposed to assume that this is, for example, positive terminal. So when current enters the component, you're supposed to always write positive sign. Anytime current is leaving component, you're supposed to write negative sign. Positive, negative. So if you want to find voltage VAB, you're supposed to simply add voltage drop across resistor and add the voltage drop across the inductor, because I have positive sign. So if you're going from A to B, you see positive. That's why you are going to have positive VR1 plus VL. So VAB is equal VR1 plus VL, where VR1 is equal 45.25 volts and angle of 30.42 degrees, plus VL, which is equal 59.24 volts and angle of 120.42 degrees. This is equal 74.54 volts and angle of 83.04 degrees. So we found voltage VAB, we found voltage VRVL, we found total current, and we found Z total. So we can say that problem is solved. If you want to check your answer, you're supposed to find voltage across resistor R2. So VR2 is equal I R2 times R2, where IR2 is equal 125.72 milliamps and angle of 30.42 degrees, times R2, which is equal 470 ohms. And this is equal 59.08 volts and angle of 30.42 degrees. If you are going to subtract from voltage source voltage across resistor R2, you're supposed to get voltage VAB. So let's check what we are going to get. VAB is equal voltage source minus VR2. This is equal 120 volts and angle of 60 degrees minus 59.08 volts and angle of 30.42 degrees is equal 74.56 volts and angle of 83.02 degrees. So please notice that we got VAB in two ways, and both values which we obtained, 74.56 and we get 74.54 and angle 83.02 and 83.04 are very close. So it means that the problem is solved correctly.